The Earth has come to exist with a plethora of natural systems and cycles in which the environment and its inhabitants find itself cohabitating with. Over the rapid development of the human race, we have created a series of negative externalities which now inhibit these cycles and threaten not only ourselves but all life on the planet. For example, some of these negative externalities are pollution, such as an excess of plastics found in our world's oceans, overdevelopment, and the relocation of non-native plant species. On top of countless others, the current greatest environmental externality we face is anthropogenic climate change through the global warming and an increase in carbon dioxide, which is released from the main method of energy used by humanity, the combustion of a variety of resources from coal to oil to natural gas to wood in order to power steam-powered engines. Drafting effective international policy to combat these externalities has proven to be one of humanity's greatest hurdles to face, although we have come together before and we can do it again.
Make up our planet's ozone layer. Despite their tiny size, our ozone defenders are amazingly strong and smart. They let in the sun's life-giving warmth, whilst keeping out the deadly UV rays.
In 1973, the discovery that our planet's ozone layer was beginning to form a hole over the continent of Antarctica had been made. The hole came from an abundance of ozone-depleting substances such as chlorofluorocarbons and hydrofluorocarbons found in refrigeration units, pesticides, and air conditioners. This alarming discovery led to one of the most successful international agreements in history. With a strong phase-out management plan for ozone-depleting substances and the participation of over 197 countries, the implementation of appropriate action to mitigate further damage to the ozone was implemented, a mere 14 years after the phenomenon's discovery. 2019 was the smallest recorded year of the ozone hole since 1981.
I don't envy the scientists who are tasked with monitoring the hole and how it's changing, because it's in the stratosphere, for starters, and it's over top the least populated, most remote and challenging continent we have to work with on Earth. In addition to the fact that because temperature and light intensity are factors that go into ozone depletion and generation, and those factors are dynamically changing as well with respect to global climate change. It's an enormously complex system that I wouldn't want to comment on further than what I have just said about how I admire the complexity and am intimidated by it, and very glad that I'm not working on it personally. It's a lot easier when there's just a handful of stakeholders who are producing this stuff that you need to modify their behaviors. When it is so many sectors across so many different economies that depend on carbon emissions, then that's what makes it more unique compared to the Montreal Protocol when it comes to carbon emissions. So it can serve as a model, but we have to recognize the fact that there is a big disparity there in terms of the scope.
As Dr. Utes says in the interview, although there are broader economic implications to reducing carbon when compared to ozone-depleting substances, there is and will always be a recorded event where the health of the planet took precedence over our willingness to adapt for it.